Here. Well, good morning. I hope most of us are here, but if any more come in, either David or I will let you in, or your friends. Tell them they can still come. This morning, we are very honored and thrilled to have an old friend of my husband's and mine because my husband works with David some of the times. They see each other at meetings and everything. So we have known David for, gosh, 30 some years, I guess. And what we're exploring today with David, and he's probably one of the few who can do this, is to show a true balance between science and then processing science into your art, and also his life, because that it's like a tripod. The life is also there. The life is scattered into the science, but his life is also an ingredient in his art. And David has something really surprising in store for us, so I won't keep belaboring the points. And I will tell you that he works at Kitt Peak, as it says, as an observer on the telescopes, and he will tell you all about which telescopes. And I will, at this point, take it over to our very eminent speaker, David Lee Summers.
Well, thank you, Gloria. Thank you so much for having me, and thank you all for coming. And those of you who are watching later, thank you for watching. My name is David Lee Summers, and as Gloria says, I'm an astronomer who works as an observing associate at Kitt Peak National Observatory. And basically, this talk is talking about how my work how my work in astronomy inspires both my writing and my life. I'll talk a little bit about that. I will say that one of the things that has happened in this last year and talking about life is a combination of both helping to raise my daughters, and I have also had the unfortunate news this year that I have developed prostate cancer, and I'm beginning to go through treatment for that. And I have actually found that life in the sciences, learning how to evaluate things, learning how to look at things, learning how to look at things as dispassionately as possible has actually really helped that journey as I've had to kind of make decisions and evaluate things for myself. So just moving on to the next slide here. Let me make sure I can do this the correct way. Let's see, looks like, make sure it's seeing, there we go. So my telescope operation work is that I work at the two largest telescopes at Kitt Peak. If you can see my mouse, basically the one on the left is the WIN 3.5 meter telescope. That is one of the newest large telescopes at Kitt Peak National Observatory. And then I also work at sort of the grand old telescope of the mountain, which is the WIN 3.5 meter. That's where I've worked with Gloria's husband most, is on that telescope, looking for near Earth objects. And but that telescope's mission has changed, and we're going to talk a little bit about its mission, and we're going to talk a little bit about the WIN's mission that are going on right now and how those have influenced aspects of what I do with my writing, and how they've also come into and influenced my life as well. And as a writer, I have written some 13 novels right now to date, and just a couple of months ago, I sold my 100th short story. They range from science fiction to different aspects of fantasy and horror as well. In fact, my latest novel is called Ordeal of the Scarlet Order. But despite our sort of scary looking monster on the cover, on this big cover, it is actually, I think I would argue, one of my books I kind of bring a very hard science fiction sensibility to. And I'll talk a little bit about how that comes in as we get a little later into the talk. But most of the books I've presented up here are sort of science and science fiction related books that I've written. And of course, if you want to explore all of my writing, go look at the whole variety of it. I encourage you to go visit davidleesummers.com. I'm just going to quit one thing in the background here so it doesn't interrupt us. And moving on here, I'm just going to kind of, there's a little bit of a pun here in that the picture is a Clark camera, which is named for Alvin Clark, who was an astronomer back in the Victorian era. It's also the telescope that I had my first paying gig in astronomy. I worked at Maria Mitchell Observatory on Nantucket Island in Massachusetts, um, literally taking glass plate photos of variable stars and using those in the 1980s as a way to measure variability of stars and publishing papers. And I ended up giving my first talk in astronomy at Harvard College Observatory based on work I did at Maria Mitchell Observatory. Literally, it was hand tracking, it was clockwork, 19th century technology. And I raise that because really of Clark's three laws, there are two that are going to kind of come into this talk here and there. And, number one, we have these were presented in three different presentations that Arthur C. Clarke did. And I think there is a certain amount of truth to all of these. And number one is when a distinguished but elderly scientist states that something is possible, he is almost certainly right. And when he states that something is impossible, he is very probably wrong. That probably won't be as much a part of my presentation today, but one thing that has been a feature of my career is really Clarke's second law, which is the only way of discovering the limits of the possible is to venture a little way past them into the impossible. And and then the other one is, of course, the third one's the famous one. Any sufficiently advanced technology is indistinguishable from magic. And I should explain that when I think of magic, I often think of some of my magician friends. I have some that work as professional magicians. And to some degree, to me, magic is really, it only appears to be sleight of hand, and it only appears to be magical until you actually know how to do it. And a lot of the process of science is learning how things work and how to do things. So that's kind of my take on number three. It does come into my science fiction from time to time too, as people explore and learn how to do things. But certainly Clarke's second law, the venturing into new territories with even equipment and techniques that we might not have thought are possible, has definitely kind of been a theme of my career over the years. Now I'm going to start out with the WIN telescope. This is the 3.5 meter telescope at Kitt Peak, as I mentioned, and what we're looking at on the left-hand side is we're looking at the telescope itself, and the big black box, if you can see my mouse, and if you can't, it's the big black box about the center of the picture with a circle in the middle of it. That is that's the NUID port adapter. And the instrument that's taking the most amount of time as far as observing with WIN is NUID. And it's an instrument that's designed to look for exoplanets. Basically, it's following up on NASA's Kepler mission and NASA's TESS mission, both of which Kepler was aimed pretty much at one place in the sky and trying to find just as many exoplanets as it possibly could in that one narrow part of the sky. TESS had more the mission of looking for the very nearest exoplanets. And this instrument was built to be a long-term follow-up instrument on those. And so what happens is light comes down into the telescope, bounces off the big mirror here in the big blue base at the bottom, up to the secondary mirror, down to a third mirror in the center, and off into the instrument, where a fiber optic that is fed with adaptive optics leads light down through a fiber 2 stories below into this almost sarcophagus looking thing on the right. And that thing is a very high resolution spectrograph. And we'll talk a little bit more about what spectrographs do in the next slide. But short answer is what we do with spectrographs is we use them to look at, they're an astronomer's way of understanding the chemistry of how stars and how atmospheres are made. And they're very important because we see lines in spectra. Those characteristic lines, or the fingerprint of stars, are how we know what they're made of, but those lines can be affected by the motion of those stars. And that's pretty much what NUID is looking for these very tiny, tiny motions in the stars. In fact, they're so small, they're almost atomic scale. And I'm going to draw your attention mostly to the figure here on the right-hand side, which is, this is an actual spectrum in the center here with all the dots next to it, an actual portion of a spectrum that NUID has taken. And, as it shows from the right-hand side, it's just this little tiny portion of the entire spectrum from the infrared down to the ultraviolet at the bottom. And each of those dots is a calibration image from something we call a laser frequency comb. And this was actually a Nobel Prize winning technology that was designed to put really precise dots on our images. As it shows there, it's only 0.024 nanometers. We're like talking about, we can measure shifts of these lines down to literally like femtometers, which is very, very tiny. And basically what happens is when a planet is going around its star, as the planet comes between us and the star, it pulls the star just a little tiny bit toward us. And when that moves these dark lines that you see in the spectrum a little towards the blue end, or down in this image. When the planet goes behind the star, it moves the star a little bit away from us. And that means it moves these lines a little bit to the red. And that's what we mean, what astronomers mean when they talk about redshift. Now, redshift actually translates into a kind of velocity. And what we see in this image over here on the left is that Earth only moves the sun at about a speed of about 0.23 miles per hour. And just, because most of us are based in Tucson and here in the desert, we have kind of a fun comparison of what that speed is relative to desert animals. So a Jupiter moves it closer to 30 miles an hour. That's a little more like a rabbit you might find up on Kitt Peak. But Earth only moves the sun at about 0.23 miles per hour, which is much closer to the speed of a desert tortoise. And that's where you need these very, very fine levels of detail to go into. Now, the way NUID actually works on the telescope is it's what we call Q observing. And that means that every observer who wants to use NUID applies for time. Each of them get a certain amount of time, and then an observer decides based on the conditions for a given night which thing has based on both the top scientific method merit and the conditions that we have at the time, which things get observed in what order. And so we have a number of different, so mostly I end up working with in-house people. And most of this data ends up going back to them, and it's proprietary to the universities and such. So I can't really share a lot of very specific results, although I have seen, I do follow a lot of the exoplanet science a lot. And I think where this actually comes into a lot of my writing is, of course, these things, I see things even in the data, even in the limited amount of data that we have about exoplanets so far, I get a lot of fodder for types of planets that we might not have easily imagined in science fiction to this date, and even ways that we might imagine visiting these planets. And just to kind of step back a little bit, One of those scientists that I have worked with quite a bit is, this is me, the picture there on the left is me with Dr. Steve Howell, who used to be the telescope scientist for WIN a number of years ago, but he left us to go to work for NASA. And he was the Kepler Space Telescope mission scientist for NASA, but he continues doing a lot of work in exoplanets. And as I mentioned, my daughter, as far as life kinds of journeys, both of my daughters ended up actually working either indirectly or in the case of my younger daughter, directly with Dr. Howell, in that my older daughter, who ended up going to work in computer science, ended up developing a machine language, or a machine learning rather, algorithm for detecting planets out of Kepler data. My younger daughter ended up actually working with Steve on how to find planets around, the numbers of occurrences of planets around binary stars. So if you think about Star Wars, you think Luke Skywalker looked up into the sky, and of course today is May the 4th, Star Wars Day, so that's very appropriate today. He looked up in the sky and saw the two stars in the sky. Fact of the matter is one of the things that Kepler discovered that I think a lot of us in science fiction were a little surprised by, was that in many cases, what happens is when you find planets in binary systems, the planets tend to orbit one of those stars. They don't tend to orbit both of them, and planets tend to form when the stars are fairly far apart. So you tend to start seeing planets when one star, say if we imagine one of the stars is where the sun is, if we had another star in our solar system, that other star would be out around like where Neptune is, or Pluto even. So the stars end up being quite far apart. So that other star might look quite tiny in the sky. But again, as far as where this intersection of science and fiction came in, that was one thing that was really fun, was Steve and I, on one night of observing, were talking about, the whole notion of back in the Victorian times, you had people like H.G. Wells and Camille Flammarion, who were very interested in imagining what worlds might be like, what Mars might be like, what Jules Verne imagining what the moon might be like. Camille Flammarion, who is a name we don't know of a lot in the US, but wrote popular science books. I like to think that Camille Flammarion was essentially the Neil deGrasse Tyson of his day. He is the person who, he was writing the popular books that inspired Percival Lowell to go build an observatory in Flagstaff. So just to give you an idea of what kind of influence he had in the world. He also influenced a lot of Jules Verne's science fiction at the time. But we were inspired by the idea that these writers were imagining planets that had been light in the sky as real places. And we got to thinking, wouldn't it be fun to start imagining these planets that Kepler was discovering as real places, and imagining what it would be like to visit them. NASA has a long history of employing artists to paint pictures that imagine what these planets might be like. But Steve said he had very little recollection of anyone looking into doing it through story and through writers doing that. And so the upshot is that we ended up editing 2 anthologies of stories where we asked science fiction writers, some of them are fellow scientists, but some are pure writers, to come and submit stories submitted around planets discovered specifically by the Kepler mission, which Steve was a project scientist for. And those were a Kepler's Dozen right there in the center, and then Kepler's Cowboys, the kind of yellow cover. And just to give you an example of some of the kinds of exoplanets I've explored in these books, is in a Kepler's Dozen, I looked at what we call a hot Jupiter. And when I went through undergraduate and graduate school, the whole notion that we might have Jupiter-sized gas giants in the inner solar system was we thought that would be unlikely. All kinds of explanations were developed about why it is that you have to wait until you get to about the midway through our solar system before you start seeing gas giants like Jupiter and Saturn, and ice giants like Uranus and Neptune. And we thought those had to do with how far they were from their stars. But one of the things that Kepler and other exoplanet searches found really quickly was that you have a whole lot of Jupiter-size gas giant planets that are in orbits almost tighter than Mercury. And so I thought, actually imagining a visit to one of those worlds. Of course, you can't land on such a planet. You obviously, any starship you're going to send there is going to have to be a very robust starship, and it's going to give them all kinds of problems. But that was the whole reason is for the story is why they had to go to this particular place and endure this particular thing for a short time before basically everything on their ship was fried and destroyed, and they had to get away from there as fast as they possibly can. In the anthology Kepler's Cowboys, the ideas were basically exploring the whole space cowboy idea, but imagining it on planets discovered by the Kepler mission. And what I explored there was a type of planet that we do not have at all in our solar system, and that's a water world. And we often, talk about the idea that Earth is a water world. But in fact, when we're talking about a water world, we mean a world that has basically the density of water. When we look at Earth, Earth is actually a rocky world. It's rock all the way through with this little fine coating of water on the surface of it. Even deep as the oceans are, they don't really go very far towards the inside of the Earth. So, but there are actually worlds out there that have largely the density of water all the way through, or at least that's how they measure out. So a very large part of their outer surface is a water density kind of planet. So I thought, so in Kepler's Cowboys, I take characters to one of those worlds to see what it would be like. And then both the stories from those became part of my science fiction novel, Firebrand's Legacy, and I got to explore other types of planets that Kepler and then Tess have discovered, and we've been looking at with NUID as well. And one of the things I'm actually kind of proud of with all of this is a lot of people will talk about their holy grail as a writer is to get a review in Publishers Weekly, especially a starred review in Publishers Weekly. And that is something I seek. And whenever something I'm in, or an anthology I'm in, or one of my books is reviewed there, that's really exciting too. But pride of my life was when both A Kepler's Dozen and Kepler's Cowboys became recommended feature titles in Physics Today. And Melinda Baldwin, who is the book reviewer for Physics Today, basically said of Kepler's Dozen, if you're in the mood for science fiction that's heavy on science, pour over this enjoyable collection. And that just really touched me, and people like Mike Brotherton, who has a story in Kepler's Dozen, and Steve is actually getting recognized that we did some science fiction that actually passed muster with scientists. And another tribute we had was about a year ago in Analog magazine. There was a writer did an article on tropes that he was addressing. He was doing, I think, a series of tropes that science fiction often gets wrong. And one of the tropes he was addressing in this particular article is the notion of a starship goes to a new star system, and the first thing it does is scan around to find out what all the planets are. And then they decide what to explore from there. And the fact of the matter is what we know from the Kepler and the TESS missions and NUID is that's not the way it's going to work. We're going to look at these stars and we're going to know what planets are in orbit around the stars long before we go there. And again, our anthologies were called out as anthologies that actually got what that element of the future might look like a lot more than some other anthologies. So very proud of that particular achievement. Now, taking this back the other side, Steve, of course, being project scientist for the NASA Kepler mission, put together the AAS book that collected papers about various findings of the Kepler mission. But he also asked me to write an article for this, basically looking at the science fiction, any science fiction that has started to look at real exoplanets. Turns out there's actually not a lot of science fiction, or at least as of the writing of this book, not a lot of it has continued to has used the real exoplanets that have been out there. So that is actually a field that certainly people looking to write science fiction. It's kind of an untapped resource, even with what we have done so far, our first little beginnings of this. Feel for, go out there and look at what's written about the exoplanets and see what you can use and what exotic things trigger ideas. But yes, I was very proud to write an article in the NASA Kepler mission about science fiction. And I also, of course, in that talked about the fact that Kepler wrote one of the first science fiction stories, his story about visiting the moon and sailing to the moon, which while he didn't quite know the principles of solar sails, he almost imagined a sail mission to the moon. So I got to talk about that in there, and that was actually the first Steve knew that Kepler himself had written science fiction. And another thing that happened that's a little fun intersection of all of this, and this actually happened on my birthday in 2019, so right before the pandemic. Those of you who are Star Trek fans may remember that Star Trek Discovery introduced Captain Pike and Mr. Spock and all of this to the Star Trek Discovery universe. And we heard that Mr. Spock was on the mountain. And of course, it turns out that it was Ethan Peck who played Spock on Star Trek Discovery, and who we didn't know yet, but would ultimately play Spock on Star Trek Strange New Worlds, which is the prequel to the classic original Star Trek. And he wanted to come and actually see how scientists actually do science. So he essentially outed himself at the visitor center and said, I'm Ethan Peck, I play Spock on Star Trek, and I would, if there's any chance of seeing behind the scenes at some of the telescopes, I'd love to. And he came up and spent about half the night with us at Wynn, and was very generous and took pictures with us. This is actually me with him standing in the entranceway of Wynn. And I like to think he brought a little bit of what he saw of us interacting and working together, observing literally Strange New Worlds with Newid, to his role of Spock on Star Trek. And I also like to say that you've got an important project when Mr. Spock himself comes and joins you for the observations. Now, I'm going to kind of shift gears over to the other telescope that I work on the mountain. And this is the Mayall telescope, which is the largest telescope. It's kind of the grand telescope of the mountain. It's been there since basically 1970 was when it was built. I have operated this telescope. I started operating this telescope in 1993. And I left for a little while. I came to a job at New Mexico State University when my kids were born, but came back to the Mayall in 2008. So I've had about 19 years total operating this particular telescope. The picture here is before the current instrument that's on it, called DESI, which is the Dark Energy Survey, or rather Dark Energy Spectrographic Instrument. this picture is from before that was installed on the telescope. And the way this works, again, if you can see my mouse, but it basically, the light comes into the telescope. There's a 4-meter mirror down here in this big white area with the 3 squares together on here at the bottom. Light comes down there, and it either goes up to what we call a prime focus instrument up here in the top, or a mirror could, in those days, could be put in place, and it'll bounce the light down to the bottom here. When I worked with Bob McMillan on this telescope, oftentimes we had a camera up here at prime focus, and that's what we would hunt for asteroids with. But we would often use this telescope to look for to take spectra and to look at objects with our spectrographs down here. And we also often had infrared cameras down here. And one of the things I wanted to point out from this is, working in this kind of job, I get to see all kinds of people doing all kinds of groundbreaking science. Because they often take it home, and work on it at their home institutions, I don't always get to see the final results until published papers come out. But there was one particular set of data that came in that really, there was one particular set of data that came in that really sparked my imagination. And this was back in the 90s. It was an imager called IRIM, the infrared imager. And it was an astronomer named Mark Dickinson was taking data that was at that time the deepest image ever taken of the center of our galaxy in the infrared. And I went to look for it to see if I could find an image of that in the Kitt Peak archives. I couldn't find that, so I have to kind of cheat here and show a different infrared image. This is actually the same basic region of space as shown by the Spitzer Space Telescope, but it still gives you that idea of just this just very fascinating, mysterious part of space that's dust and gas and stars packed in tightly. And of course, we know buried in amongst all of that dust is the black hole at the center of our galaxy. And it just really sparked my imagination. And I knew I had to find a way to eventually imagine characters getting to the black hole at the center of the galaxy. And I knew this would be a real technical challenge, and I would have to develop that over the course of some
Nothing,
time.
I'm good. I'm fine. I had the mute.
There we go. Okay. So we come in, and so those books directly influenced my Space Pirates Legacy books. I already showed the first one, Firebrand's Legacy, which has a direct tie to the exoplanet data I did. And the first one of the next one of these books, The Pirates of Sufiro, very much took a lot of inspiration from also kind of what we've learned about exoplanets. As new editions have come out, I've kind of fleshed out what the planet Sufiro is like, how it's alike and different from Earth, how it might have formed differently, and how that might have created the conditions that influenced the plot of that story. I have over the years worked with astronomers who have studied globular clusters. These are sort of ball-like clusters of stars that orbit our galaxy, and that became part of Children of the Old Stars, the middle book in this set. And then finally, as the technology and as things developed for these characters, I found a way to get them to actually imagine. In this case, they actually get a probe effectively into the center of the galaxy, but because of the way the probe is like, and because it's the far future, and I imagine allowing kind of holographic technology to allow them to have to visualize it the way they want to visualize it. We basically have our characters visualizing sailing to the center of the galaxy on a sailing ship. Maybe not, again, a little bit of an homage to Kepler imagining sailing to the moon on a sailing ship. Again, they don't really do this at that sort of a whimsical part of their way of visualizing what happens in the story, but it allowed me to kind of just imagine and imagine what it would be like to sort of see the very center of the galaxy as close as possible with our own eyes. And I think that's one of the things that I love being able to bring that and hopefully inspire, people of all ages, to be interested in science and astronomy through this kind of writing and this kind of visualization. And you can say things there and have it as part of a plot and as a background of a plot that engages people, I think, in ways that a simple description might not. So I mentioned that this is in the era before DESI. DESI, the dark energy spectrographic instrument, is now the sole instrument, for better or for worse, on the Mayall telescope. Unfortunately, that means I don't get to work with Bob McMillan as much as I used to, but it is a fascinating instrument. I bring up our 5-year mission, kind of continuing almost the Star Trek theme here a little bit again. Literally, this was an instrument built for a 5-year project to make the largest 3-dimensional map of the known universe. And the reason this came about is this actually goes back to work I did with Kitt Peak years ago, back in the 90s, when an astronomer named Saul Perlmutter would call up and ask us to do what we called target of opportunity observing, where we would go observe some distant supernova that had gone off. And for those who aren't familiar with this idea, as a certain type of supernova called a type 1 supernova is what we call a standard candle. And without getting into a lot of technical detail, what that means is if you know how bright, if you can measure the brightness of that object from Earth, and you can compare it to what if you can compare that to its brightness at a known distance from the Earth, and that can give you a measure for how far away that object actually is, because we know that type 1 supernovas tend to be basically the same brightness for the same part of the explosion that they're going through. And we can get a distance from that. And the result of that was what he was trying to do was he was looking at the expansion history of the universe. Of course, we know the universe started with a Big Bang, started with has an expansion era. It's expanding. We can measure its expansion now, and back in my college and grad school days, we pretty much had the notion that, well, the universe is either going to continue expanding forever at some relatively constant rate, or eventually gravity's going to take hold and pull the whole thing back together. And so you would expect the universe to either be expanding at a constant rate, or you would expect it to be slowing down. And what Saul discovered by measuring these different supernovae at different distances was the completely unexpected result that the universe is speeding up as it expands. So something's energizing the universe, and we call that something dark energy. In this case, dark means unknown. More than say it means dark as in literally dark. And so the thing is of course, having done this with one type of measurement, supernovae, it could just be that maybe ancient supernovae are somehow a little different. Maybe they're not as good a standard candle as we thought. So you really needed a second way to measure the universe. And so theoreticians realized that a property of the beginning of the universe, right as the first galaxies began to form, is you're going to have this oscillation between gravity and the early molecules and atomic structure of the universe, trying to, light pushing out, gravity pulling everything back in. It's going to create an oscillation. We know how the oscillations behave. Where you get sort of the certain characteristic places in this oscillation frequency are probably where galaxies are going to form. This means you're going to be able to get a characteristic distance between galaxies. So if you make a very large map of the universe going back to the most distant quasars through all of the galaxies now, you can look at the characteristic separation of galaxies and determine from that a distance to those galaxies based on how much further apart a big sample of galaxies in that area is. And you go back to older galaxies at a certain redshift and see how far apart they are. And that gives you, all of those things give you distances all the way back to the beginning of time. And of course, one of the things we like to say in science is, sometimes the greatest discoveries in science aren't eureka, I found it. They're, that's strange. And already in 3 years of doing DESI, we've already created the largest 3D map of the known universe. And already astronomers are kind of starting to go, that's strange, because we find out that the acceleration doesn't seem to be uniform around the entire sky. So there's something to explain, and I don't have any good answers for that, but that's a stay tuned and see what happens in this pretty exciting area of science. How DESI works is it's basically this little army of 5,000 robots. And in the very center of the picture, you see these things that almost look like pencils going through holes in a metal plate. Here is what this is showing us a picture of. And at the top end of each one of these sort of black pencil looking structures is actually a lens. And these things can rotate. And what they do is these little lenses can be positioned so that they're optimized to get a target on each one of them, like a very distant galaxy, a star, a closer galaxy. And so these are placed all in that focal plane. And by that focal plane, I mean this sort of big can that's labeled number 1 in the right-hand image, numbers. And this whole thing is this big school bus sized structure up at the top of the Mayall telescope that has these 5,000 fibers in it. And those fibers run down a big line 2 stories below to the spectrographs that are labeled number 4 down here at the bottom of the telescope. And my job along with the lead observer who's there are to be the humans controlling these robots. And we talked about this whole process of, the fact that I have unfortunately learned that I have prostate cancer. And of course, I have learned in the process of being a robot a robot supervisor, as it were. I see Bob has asked in chat whether DESI gets used in bright time, and the answer is not all the time, but it's the only instrument on the telescope. So, but being the driver of these robots and learning about the whole thing of the whole process of prostate cancer, I've learned that one of the best ways to treat prostate cancer is through this process called radical prostatectomy. And so I sort of became, I got to learn, I learned all about the process of this and how surgeons drive this, and the whole process of being an astronomer helped me kind of vet a lot of the books and a lot of the process. Of course, I started looking for books that were written by academic surgeons who actually were on top of the research to learn what was the best process for me. And I basically came into so the next slide. Oh, we'll get into that a little bit more after, but basically where I'm going to, I'll come back to the previous slide, is I did learn through the process of all of this that I learned about the whole process of radical prostatectomy, and it actually gave me a lot of confidence that this is a kind of technology. The specifics of radical prostatectomy are very different from the specifics of DESI, but a lot of the principle of a computer-controlled operator operating a bunch of arms doing very precise work and not running them into places that you don't want them to run into is all very much like work that I do. So it helped me learn to ask questions. I, of course, had to learn about the specifics of the surgery, but it allowed me to ask questions that I think were very prescient to everything, and it allowed me to read a lot of these results and think about them and see, understand the kinds of testing that had been done. And I was actually very pleasant. I mean, it's kind of an unfortunate reality of prostate cancer that it is the most common cancer in men. And I've been writing about it a little bit on my blog as I learn things at davidleesummers.wordpress.com for anyone who happens to be going through this themselves. And I just, in fact, about a week ago, shared a book I found very, very valuable that was recommended to me by one of my fellow authors who's also going through all of this, but it was written by doctors at Johns Hopkins University, called Dr. Walsh's Guide to Prostate Cancer. And that is written by, basically, it's actually written by the entire team of physicians at Johns Hopkins. And that was very helpful to me. But it gave me a real respect for the kinds of numbers that they were saying as far as success rates. And those success rates have given me a lot of comfort to this point. To just kind of finish off a little bit with DESI, in case anyone's not quite picturing what we're able to see with all of this graphic here shows basically all those 5,000 packed fibers and what it looks like if you project that on the sky. So it's almost like you're looking through the fibers to the sky in this particular image. So you can see that a lot of the fibers are here on the Andromeda galaxy, but some of these fibers that look like they're just pointed at some part of deep space are actually pointed at things like distant quasars. And we adjust these fibers and we continue to point like literally every 20 minutes with DESI. So we take an image, it's a 20-minute image, and then as the telescope is slewing, we completely reconfigure this thing for the next field. We get on target, it's configured, it looks at cameras that are mounted in each one of these little cutouts on the side. It figures out where it's pointed, and it points itself in all of that time. It really is, compared to my beginnings in astronomy, where I literally sat there and looked through an eyepiece and held a hand paddle and touched my little clockwork controls to adjust the speeds of the telescope and hand guided an image. This is very nice, and it allows me to look at these things and think about how astronomy, what areas of astronomy can influence the next story I might be writing. So I'm going to just kind of finish off the presentation. I know we're getting close to an hour here, with a little bit of a whimsical side of this, and to talk a little bit about my very most recent book that's out, just was released in February. And my cover artist was Chaz Kemp, who we kind of see this character that I have on the screen as bears a little more than a passing resemblance, I will say, to Chaz. People who have been to Tucson will recognize Chaz. And back in the 90s, we used to joke that those of us who operated the telescopes at Kitt Peak were we used to joke that we were the vampires of the mountain, because you would never see us unless the sun was down. So yeah, we kind of joked that this was the perfect job for a vampire. A vampire could come here and show up after dark and open up the telescope, or after sunset open up the telescope, retreat to his coffin before the end of the day. And this kind of was just just a thing that we played with and batted about. And these were the days when we had solar observers at Kitt Peak. So there was the day side of the mountain and the dark side of the mountain, and we would of course be the dark side of the mountain, or the vampires. But it began to percolate in my and this is kind of how some of these things can grip you. I began to think about what would happen if a vampire really were a telescope operator. How would that actually work? And so I developed this character who was actually a vampire astronomer who operated telescopes at Kitt Peak. He ends up moving on through the course of the stories. And when we did the new edition, I wanted to do some of the actual characters from the book on the cover, and Chaz, being African American, asked, why are all these vampires white? Can't we have an African American vampire? And I thought, certainly being the scientist, I thought I really wanted to have that kind of inspiration of an African American scientist in the stories, who just happens to be a vampire. But of course, this ended up leading to my novel, Vampires of the Scarlet Order. And the two of the characters on here are scientists that are very interested in finding out where vampires come from. And of course, they're going to find out that there's an actual natural explanation to them in the existence of the stories. And being that I do, yeah. And Bob mentions, don't forget that Morlocks also are night workers. That's the little story I have about that, just as a brief aside, is I used to live in the basement of a dorm at New Mexico Tech, and all of us who lived in the basement were known as the Morlocks. So I definitely have a connection to that bit of H.G. Wells as well. But yeah, so at some level, this whole process of, if I'm going to write a vampire story, it's not going to be your classic magical vampire story. I'm going to have a story about, where is it that the vampires come from, and what conflicts that might raise up. And that led to me creating Vampires of the Scarlet Order, as well as Ordeal of the Scarlet Order, which is the new sequel that's just out. And had a great amount of fun. And I would actually argue that even though these are quote unquote vampire novels, they really make me bring my A game of the science, because they're actually set in the present day. And I try to make sure that all the science that's presented in the books is as possible as they can be. I won't give you spoilers as to what they find is the background of why there are vampires, because that is kind of a spoiler for Vampires of the Scarlet Order. But I will say they end up finding out that it's a natural background. They do find that, yeah, there's a little bit of stuff that looks like it ought to be kind of magical, going back to Clarke's third law, but it turns out that's just because they haven't figured out how it all works yet. And so they're figuring out how it works in now the new book. And that's pretty much what I have in the presentation. And I'm happy. Oh, I did just present up here a brief. I was going to just quickly show off. I mentioned 100 short stories. These are the most recent 6 short stories I have out in publication. These books are all out. They're a little bit of a mix of steampunk and horror. Arithmophobia looks like it might be a little bit about the fear of math, but it's actually horror stories that all have to have some respect for the discipline of math in each one of the horror stories. And I was asked to write a story in that precisely because of my astronomy background. So I'll go ahead and stop sharing my screen. So if we have a few minutes to chat a little bit, I'm happy to do so or answer any questions.
I want to thank you so much, David. And this was a very inspiring talk because of the way that you seamlessly brought in your life events and the diagnosis, and also just how you relate, how you use your science and everything you're experiencing in science to, I mean, it's 3 points that keep swirling around. So I don't think we've had a speaker like this before. And that's saying something. We've had all kinds of speakers. But thank you. This was a unique and wonderful presentation. And I see that we have a hand already. Tim Saba has his hand up. Where is Tim? Okay, Tim, where are you?
He unmuted and then he muted again.
Oh, okay.
Oh,
So
okay, here I am.
faster.
Sorry, this is a very, very inspiring, actually, talk. You did explain complicated issues in an extremely well way. I think your students are very lucky to have you as a, you know, as a leader. I mean, absolutely wonderful. And I wish you a great journey in recovery from your cancer.
Thank you very much.
Absolutely, yes. And I have a few questions, but I will let other, I'm going to ask one or two, one, and then others, really expired. There is years ago, there was this barrage or preponderance of articles and stuff about Planet X, Planet 9. And there was a lot of talk about it, and then suddenly, I don't want to use the word suddenly, but almost suddenly there was no more talk about it. It's almost like somebody said, "Don't talk about it anymore," because somehow this planet, if it is true, and it kind of approaches us in its elliptic orbit, it might really affect us. And some people call it even planet Nibiru or something like that. What is your thought about this?
Well, that's not really my expertise. I see that Bob unmuted, and I think he might actually know a little bit more about that since he does a lot more solar system work than I do. I will say I did just see a very good summary from the Planetary Society just this week, kind of talking about research continuing in that area. So I suspect a lot of it is probably news cycle kinds of things. It just kind of fell out of interest of the more popular press. But my understanding is I think searches for a ninth or a Planet X are continuing. Bob, do you have anything to add to that?
Yeah, I think the original thought of a Planet X was motivated by the finding that the outer solar system trans-Neptunian objects were distributed around the sky in a non-isotropic way, an unusual way, that they thought might have been due to the gravitational effects of another planet out there. And those early computer simulations tried to take out the observational bias in where these objects tend to be found. It turns out that sort of October and November in the Northern Hemisphere is the best time to find trans-Neptunian objects because the ecliptic is high, it's away from the Milky Way, and the weather is good. And so there's this very strong observational selection effect on where these objects tend to be found. And if you don't allow for that effect, then you're going to think that there's some systematic perturbation of a gravitational object out there. And I think that the selection effects due to observational bias were not sufficiently allowed for in those early studies. And so the theoreticians backed off on that. And there have been later attempts to model the observational process to see whether it is still possible to find the effects of another planet without having uniformly sampled the ecliptic all around the sky, which is very difficult to do due to the Milky Way and the tilt of the Earth's axis and so on. And it's still very inconclusive. There are studies that suggest there might be a planet in a certain area of the sky that hasn't been sufficiently surveyed, but there's another possible explanation for the weird distribution of outer solar system objects, and that would be a temporary encounter of our solar system with another star. And if that happens, then, and the star goes away, you have the solar system all stirred up, but then the star is gone. So there's nothing left to look for. So this issue of Planet X is still being kicked around by both observers and theoreticians. I don't anticipate a resolution of that in the near future because the observational difficulties are so strong. We can't observe into the Milky Way. We can't observe when the ecliptic is down low in the sky and so on. So I think it's just going to be one of those enduring mysteries.
Okay, thanks. I learned a lot from that. So thank you, Bob. Evelyn?
Evelyn?
Yes, I'm going to ask in another direction entirely. How did you develop your plot, characterization, novel writing skill?
So I've been interested in writing for a long time, and pretty much, just to give you, I'll just kind of step back and talk about, when I was a young kid, how I first got interested in writing was literally by watching Star Trek, and I noticed that there were all these writers who I could look up at the library that wrote books, people like David Gerrold and Harlan Ellison and so on and so forth. And Alan Dean Foster was writing novels, or writing adaptations, as was James Blish. And these were sort of my gateway drug into science fiction. And then then David Gerrold wrote a book called The Trouble with Tribbles, which is his actual not just the plot of his famous episode, but it was actually his story of how he developed that script and how he sold that script. And when I was about 8, 9 years old, whatever age I was when that came out, and I read it, was sort of my first real eye-opening notion that I could, that writing was a career I could maybe aspire to. And so I began kind of just learning what I could about it, and taking, paying special attention in English classes, and developing, learning how to develop plots and characters. And, when I was in high school, I had the fortune of meeting Ray Bradbury. And, he talked about going to the library and reading all of these books and using that as a method for getting to know his plots and characters. And so a lot of it is taking that. And of course, I went to my parents and said, I want to be a writer. And they kind of shook their heads in despair and said, what are you going to do to make real money? And I said, well, I could always be an astronomer. And then they again shook their heads in despair. And so, so it goes. But as far as the specifics, it's like my specific method is I tend to be a plot forward kind of writer. I tend to well, I probably tend to be a character forward driver in the sense that my characters are usually where I start. I usually start with a set of characters in a particular circumstance. But then I start, especially with my novels, I start outlining various plot points that I'm going to try to cover over the course of that novel. And my outlines actually are really just a series of bullet points, and each bullet point is something I'm going to cover in I want to explore fully over the course of the book, and that's how I kind of develop that in a way. But where I started with Pirates of Sufiro with Firebrand's Legacy basically was I had this idea that I wanted to tell a story about a space pirate, and so my space pirate did become that very first character. And who were the members of his crew, what kinds of things complemented his skills and what things didn't complement his skills, what would he look for in a crew. And what happens if you throw in a crew member who's maybe a little bit has their own interests at heart, at opposition from the crew, as you might in a pirate crew. And you sort of start with those characters and then see what kinds of plot elements they're going to drive through. And some of my earliest books really were what you would call fix-up novels, where I just started with a few short stories in a sequence of short stories.
Oh, I
and
see.
turn those and then let them develop for 4 or 5 stories, and then oh, okay, now I see a thread of a novel developing, and those can become, in Pirates of Sufiro, those became very widely scattered chapters, and other books I've done, sometimes when I've done that process, they've become like the first 3 or 4 chapters. So it really depends. That kind of varies from book to book.
Well, it's a marriage made in heaven that you did both, and I'll tell you, I've been to Kitt Peak. When I came to the Tucson Festival of Books, where I got connected with this sci-fi organization, I took the tour to Kitt Peak, and now you've given me a little bit of a greater glimpse behind the scenes.
Oh, great. I think I saw Gloria had raised her hand.
Yes, I did. I was wondering if you got any of your technique of discovering your stories in discovering your longer work in your short stories from all that documented practice that Ray Bradbury did.
Oh yeah, I mean, it was, I guess I met him when I was about 16, which is a great age to meet someone like Ray Bradbury, because it was right at the right age to just start, as he would say it, go through my life with my eyes wide open. Anything can be a story idea. Anything can trigger an idea. Like I say, that's exactly where this whole notion of a vampire telescope operator came from. Is it was just us joking around on the mountain, and then me kind of sitting back and rubbing my chin and saying, well, could that be a story? and running through that. And I've certainly done the thing where I've needed a story, and as he talks about, he talks about sometimes, or he would talk about sometimes, writing lists of nouns, and start just seeing which one comes to his mind. You could write the cowboy, the telescope, the superhero, the starship, you just start with all of these nouns, and you see which one triggers your subconscious, and you see where that goes from there. And I've certainly, when I've needed to write something and I've been at a loss, that has been a great way to discover a story. And I've also, not just stories, but I've used that for poetry as well. Sometimes what comes from that discovery process sometimes ends up leading you down a more poetical kind of route too.
Do you do that in your visual art? Because you're a visual artist.
Well, I do. Most of my visual art is pretty much for my consumption, but yeah, I sometimes do a little bit of that as well. And a lot of the stuff that the visual art that I've ever had published has mostly been photography, and like I have a couple of book covers that are photographs I've done. So
Ah, okay.
uh-huh.
Any other quandaries or questions or observations? That's a pun there, observations. Well, this has been very stimulating. It makes me want to run out and do some decalcomania. Oh, wait, we have Tim Saba. Go for it, Tim.
Yeah, I have the question. I wrote the question before you start talking about your actual research in robotics in the prostatectomy type. And the question was, and you also expanded that, how different it was between when you started, when you did all these observations by yourself, and now through indirect measures and stuff. And I was wondering, is there something that is lost from not observing with your direct eye like it was for a few centuries actually, and now through all these intermediary fibers and optics and sensors and all of that? Is there something lost in your opinion? Or I know we gain a lot, but I'm talking about that something that might be lost, that touch or that feeling. What I'm interested.
Well, I think just from a sort of personal point of view, a couple of things come to mind. Is one thing that's different between Kitt Peak today and Kitt Peak in the 1990s is in the 1990s you had basically every 3 to 5 days you would have a new observer come to the telescope and operate maybe a very different instrument from one to the other. But this allowed me to, one of the things that kind of comes to mind first and foremost is that I've kind of lost that interaction with a lot of the people who come to us. We used to have, got to meet people like Tyson. I got to meet people like Vera Rubin. In fact, one of my great memories is I was working with Vera Rubin at the 2.1 meter at Kitt Peak, which is a telescope we didn't talk about, a few days before comet Shoemaker-Levy 9 hit Jupiter, and we got to go look at comet Shoemaker-Levy 9 with the 2.1 meter ahead of time with Vera Rubin, which was just an amazing experience. And I got to meet people who were literally I got to work with people like Saul Perlmutter, who would go off and win the Nobel Prize for this work that became DESI. So I miss that. I think the other side of that is, when you're actually out with the telescope, you kind of have a personal connection in a way with the sky. And when you're sitting in the control room and operating the telescope, behind the scenes with the computer, you kind of feel a little more like a computer operator, and you might see some fun stuff in the raw data, but you don't quite have that same just really intimate connection with the sky. Although I do make an effort to go outside and spend some time looking at the sky, especially on the clear nights. Of course, those can be the busy nights, so sometimes you don't get time to do that, but I try to make time when I can. Bob, did you have something? I see you unmuted to add to that.
Yeah, I very much agree with something having been lost when we moved into control rooms. And my whole undergrad and grad school was done out in the dome on our feet all night in the sky with a telescope, looking through eyepieces, centering up objects, doing everything manually. and being very much connected to the weather, what the telescope was doing, looking through the eyepiece and seeing things with your eye directly. There was something about that we lost when we moved into control rooms. And I remember when control rooms were first introduced, this would have been, around 1980. We original observers thought that was too wimpy. That wasn't real observing, because you're sitting in a warm room, comfortable with computers, and that just didn't seem like the same kind of thing. Even in public viewing, I think there's something visceral about allowing the public to look through an eyepiece and see photons from a galaxy, millions of light years away, and going directly into your eye with no computer, no image processing, nothing in between, is very satisfying and awe-inspiring. So yeah, sitting in a control room, and nowadays, of course, people are observing from the East Coast remotely from their own houses. We call it pajama mode. And for somebody in Massachusetts who has telescope time on the Keck in Hawaii, that's the only way to do it, because the travel is just impossible. So there's a lot to be gained, of course, with the new technology, but there's something visceral that's been lost. In fact, I know that one of the old-time observers, Pat Romer, who used to observe comets with the 61-inch on Mount Bigelow, didn't like the modern type of observing. And she said that if astronomy had been that way when she was a student, she would have gone into some other field, like field geology, to be more connected with nature.
And I will say, though, one thing that's kind of neat is that the WIN 3.5 meter actually is one of the few telescopes of that class that you can actually mount an eyepiece to. But sometimes in instrument changes, the instrument changes take enough time that our site engineer, during the 3 nights of the instruments, one of the big major instrument swaps will put the eyepiece on. So, getting to look at something like Jupiter or Mars or some of these distant galaxies directly through a 3.5 meter telescope, that's a rare treat. At the best, that's always been kind of a rare treat, I think, for these telescopes. But I've gotten to do that, and that's just a great amount of fun and a great amount of inspiration. And I do see Elaine had a question in chat. That's a good one. That's, what do I read myself? And I read a lot of different things. Actually, not too long ago, one of my very favorite things I did is I just reread The Martian Chronicles for the first time in probably about 20 years, which was a great amount of fun to rediscover that. And after I read it before I was really a writer, and then coming back and really getting to appreciate Ray Bradbury's craft was something that was a lot of fun. I like reading of other science fiction writers. I like to read. I like reading S.M. Stirling and Walter John Williams. I like reading, I've been, most recently, I just downloaded Cixin Liu's, if I'm pronouncing his name right, I'm probably murdering it, The Three-Body Problem, which we're going to probably, me and one of the other telescope operators were planning to sit down and discuss that. He wanted to hear my opinions. Because I am a SFWA, Science Fiction Writers of America, member, one of the things I like doing every year, it always feels a little bit like running a marathon, but I like reading all the novels and novellas that have been nominated for the Nebula Award every year, and I find that those are kind of they're a great little sample of what's sort of the best stuff that's being written by authors today, and they're not always science fictional. A lot of the things in that list are definitely more fantasy and more dark fantasy kinds of books. But you know, like 2 years ago, that it was really through the Nebula reading list that I discovered Martha Wells' Murderbot mysteries, which are Murderbot sounds like, you know, they're actually this sentient AI android who has called itself Murderbot because because of its background in armaments and so forth. But it's basically kind of this whole exploration of its psychology as it goes through doing traveling with humans through the stars. And Martha Wells's series is just absolutely wonderful. So basically, I'm always reading. You know, actually, one of the things is I remember Stephen King in his book on writing talks about, you know, as a writer, you should always have a book with you, and you know, you always have these little places in your life where you're standing in a checkout line at the supermarket. And I find it right now as I'm going through all the tests, getting ready for some surgery, that gee, I have all this waiting room time. So I always have my ebook with me, so I have something to read.
I have one last question because I have to
Sure.
run too. With all these infinite mysteries surrounding our universe, this infinite expansion, this whole mysteries around it. I mean, I used to be a very committed atheist since my teens until a few years back. I started feeling that there is something divine about this whole universe. Do you not? I mean, I don't want to ask you, but do you, among your colleagues, talk about some, even in a super scientific milieu? Do you talk about some mysterious divine thing going on around the world and in the universe?
I think we all kind of tend to speculate on these kinds of things. Certainly from, you know, just another thing that is a background in my life. You know, full disclosure, my older brother is an ordained minister. So and so we've had certainly plenty of discussions between us on that sort of thing. And he has the books that he recommends, and I've long been fascinated by Bible history, which is both my brother and again, that goes back to Ray Bradbury. Ray Bradbury talked about his love of being inspired by stories of the Bible, and certainly taking those as kind of jump off points. But I would say, you know, not every astronomer I've known welcomes discussions of sort of, say, a spiritual nature, or of is there a grand design kind of nature. But certainly I have had discussions with people about that, and they have ranged from people who've come to the conclusion of they've looked at the universe and they've looked at the chemical makeup of human beings and come to the conclusion of being more atheists. And I've known others who've looked at it all and come to the conclusion that there must be some deeper, more spiritual level to the universe. So yeah, the short answer of the question is yes, the discussions do happen. They're not, you know, they're not an everyday kind of thing, but they have happened. And you know, I've gotten some very wonderful, thoughtful answers. I have even, you know, and in fact, actually one of the sort of profound moments in some of my observing was working with a very devout Islamic astronomer who actually did have to take the time to pray and face Mecca through different parts of the night and pray. And you know, it was just kind of it kind of opened my eyes to someone who came out of this from a different spiritual tradition than I really grew up with and knew.
Well,
Thank you.
that's a fascinating sidelight, and one that we haven't often heard in these discussions either. Now, if I may do a segue, I hope you won't mind, shameless plug here.
Sure.
I've written it out here. I did do a collection of essays about, that should be about Ray Bradbury, called Orbiting Ray Bradbury's Mars. And what is interesting is I have all access to all these planetary astronomers, but also literary critics and film critics. And one woman who is a literary critic, and it tells you about her there. It's an indigenous nation here in US and Canada. And she read the Martian Chronicles. Her name is Grace Dillon, and she teaches at Portland State University Indigenous Studies. And she read it on and off the reservation. And her conclusion was that Ray Bradbury was a great nurturer of people like herself, and that she might not have been able to make it if she hadn't encountered what she calls survivance stories. That's not survival. And in her essay, she talks about that the people from these indigenous cultures had to get into survivance, not only to just barely scrape by, but to develop their own subjective cosmos. And she goes into some really very touchy things. And then she refused to translate whole sentences, which was okay with me. And I said, they're not translated. And that was to illustrate that it can't be translated. So then I had to go to the editor and try to convince them, that they shouldn't translate, just leave it. And so the man who was editing the series, he wasn't the publisher, said, well, we'll just let it go and maybe they won't notice. And they didn't notice. So we got her Anishinaabe sentences in there. And it's a very important point, because as we're talking all this science, this is a Western science. And it's very important to value people in their localities, their local knowledges. This is a standardized universal system of knowledge. And we had another speaker that came to this group, and oh wait, I can't remember his name, but it was all about the coming of the railroad into the West. And that the surveyors and scientists who did the best were those who listened to the local Native Americans and Western simple people who were not educated about which way they should route it, because they knew where the floods were. And these survey tools couldn't tell them that, but these people knew it because they'd lived there for so long. Often science just runs roughshod over local knowledges, but we're getting better about that. And I'll try to remember, God, I'd have to look it up, but it was a great book too, and it was all about balancing the universals of scientific method with local knowledges. And it has to do, I wish I had enough so I could give you the title, but anyway, I think that was a good talk too. And I think he may be recorded. I don't know.
Okay. Well, thank you.
Yeah, you're welcome. The anthropology speaks here. So are there any other people that wish to be heard, or if you need to get on to the rest of your day, we want to thank David for one of the most outstanding talks we've had. And a little round of applause for David. All right, well, you'll get plenty more viewers on YouTube, and everyone else, be sure to tell your friends that they can find them on our YouTube channel. And we wish you a very good rest of your weekend, and have a good one. Nice to see you all again. Take care.
Thank you all for coming.
Thank you.
Thank you.